You can proceed, sir.
Oh, okay, sir. Good afternoon, each and every participants in the FDP. Uh, I welcome to Dr. M Sujithra, and she is a dedicated academician and researcher with 20 years of teaching experience as associate professor in the Department of Computing, Data Science at Coimbatore Institute of Technology. In 2017, Dr. M Sujithra earned her PhD from Avisalingam University, specializing in mobile device and data security. As a mentor, she has contributed to the Samsung Prism project and served as an evaluator and mentor for Smart India Hackathon 2022, contributing to NPTEL Swayam course on cybersecurity and emerging with L&T EdTech as a reviewer for in-house training programs. Her role as a conference chair, session chair, scientific committee member, and a technical program committee member in numerous international conferences demonstrates her dedication. And she is published three books in the areas of machine learning, network security, mobile malware reduction, and cloud security. Additionally, she actively participated in academic activities, serving as a resource person for the topics such as data science, artificial intelligence, and machine learning. She has published numerous Scopus indexed papers on cloud computing and data security in both national and international journals and conferences. Thank you, Sujitra madam. We are very happy to have a such nice resource person in our FDP. All the participants and the team SVCW welcomes you, madam. Now the dais is yours. You can start our presentation, madam.
Thank you, sir. Thank you for the introduction and good afternoon to one and all present here. I thank you for giving this opportunity. Then I will start this presentation. So my topic for today's FTP session is future towards generative AI models. So I will share this screen. Sir, is it visible?
Yes, ma'am. Yes.
Yeah, we'll start, sir. So the topic for today's session is future towards your generative AI models. So we will start with what is artificial intelligence, then how artificial intelligence trends towards the technology, then the emerging of generative AI, the types of generative AI, then what are the breakthroughs while using this generative AI in both positive and negative sides, and applications where you can deploy the concepts of generative AI in our day-to-day life, and in deploying and using generative AI in all our day-to-day activities, what are the issues and how these issues can be resolved. So we'll just have a look on these topics. So we'll start with artificial intelligence. So as we all know, we are simulating the human intelligence process by machines, especially by the computer systems, will make the computer system in the process of learning, reasoning, and self-correction. That is our AI. So the core areas of artificial intelligence are machine learning. So we are training our algorithms with the experience which we have gained on that particular data, the natural language processing, understanding the human language, all the semantics and the syntax, then computer vision, interpreting the visual data, both your video and image data, finally robotics, automating the entire process of the machine. So these are the core areas of artificial intelligence. The main concepts we are used in AI are machine learning, neural networks, deep learning, and we have problem solving algorithms to solve the problems in the day-to-day life. Sir, is it okay, sir? Slides moving, right?
Yes, ma'am. The slides are
Yeah.
moving. Please.
Okay, fine, sir. So what is artificial intelligence? So artificial intelligence comprises of all these components: machine learning algorithms, neural networks, natural language processing, and robotics. So the importance why we are going for artificial intelligence. The main thing is it will have the efficiency in the automation process. So AI enables the automation of repetitive tasks. It increases the efficiency and you can use the resource at the most. So these are the main reason why we are going towards the transformating technology of artificial intelligence. Then it will make the business to grow further in this process in the future. So it will help in decision support systems. So you have all your data, will have the insights on the data. So either you can go for prediction, classification, anything, any operation you can be done, and it will help you with the insights to improve the business in making a good decision. So for mainly for decision making purpose, we are towards this artificial intelligence. So if the efficiency and the decisions taken in the business are in the right way, automatically it will help the economic growth of the country, the business, everything. So these are the importance and the impact of why we are going to use the artificial intelligence. Then apart from that, you can deploy this artificial intelligence in all our aspects: healthcare, logistics, gaming. So everywhere you can use this artificial intelligence. So this is the main difference. We have a discriminative AI and also generative AI. So everywhere initially we have started with the data. We'll have all our boundary determination. From this boundary determination and the patterns, we will find the insights, and based upon the insights, we'll make the decisions. That is our artificial intelligence. So what is generative AI? Means we have prompt. From the prompt, our generative model will create the so we create the values from that, and it will specify and it will generate the own content. This is the main difference between the discriminative model and the generative model. So this is an overview where we have started and where we are going to land. So artificial intelligence, it has machine learning algorithms. Then machine learning algorithms are of three types: supervised learning, unsupervised, and reinforcement learning. So you can use your generative models both in your supervised learning and also in your unsupervised learning. You have your shallow models, deep models, then your conditional variational autoencoders, Gaussian models. So this is the way you started and you're landing in your generative models. So generative AI, as definition goes, your generative AI refers to a branch of artificial intelligence. So this is mainly designed to create a new original content. It can be either a text or image or music or even videos by learning from and mimicking the existing data. So you are generating the process of a text, image, music by learning. So unlike the traditional AI, which might classify data or make predictions, generative AI focus on producing the data. So we have a similar data. Using those data, training data, we are generating our own data. So it focuses on producing data that is similar to its training set. So the main principle of your generative AI is you have to learn from the data, existing data, and you have to generate your data. So it is trained on very large data sets to learn the patterns, structures, and relationships within the data. So you have to first learn the data and you have to identify the similar characteristics from the data. Once it is trained, these models can generate new instances of data that were not part of the original data. So it will create the new data with the similar characteristics. So it can be any piece of data. It can be image data, or it can be audio data, or video data, or text data. So these are the two principles: learning from data and generating the new data, new instant of the existing data with the similar characteristics. So this is our generative AI. So usually in our traditional AI, we have our data, we will train our model, we will find our insights, and based upon the insights, we will make our system to work. Here, you should learn from the data and you have to generate the data. So this is where our generative AI works. So it is a machine learning to analyze vast number of data. Either it can be a picture or textual data, and all these data are related to each other. Then we'll be training the exact data. From that exact data, similar characteristics are found, and you will be creating the new instant of the existing data. So artificial intelligence, machine learning, deep learning. Then under your supervised and your unsupervised learning, you can generate your own data. So this is the generative AI related discipline. Then generative AI types. So it works on numerous types, but we have listed the most effectively used types of our generative AI model. Autoencoders, variational autoencoders, generative adversarial networks, GANs, transformers, RNNs, Blotman machines, flow-based models, and neural cellular automata. So these are the most effectively used type of generative AI model. In this, we'll see the architecture, application, and how these models work on the data and how it identifies the similar characteristics from the data, then how it creates the own instances of the data. We'll see everything together. So auto encoders. So what this auto encoders? So this is a type of neural network architecture. It is mainly used for unsupervised learning. So these auto encoders will consist of an encoder network that has the input data. Then also it will have a decoder network which will reconstruct the original data from this representation. So mainly this input data is reconstructed and it forms a new instant of the original data. Mainly these particular autoencoders are used in dimensionality reduction, feature learning, and data denoising or data pre-processing, where you can avoid the noise in the data. So this is the architecture of autoencoders. You have your encoder. As we all know, we have our input data, encoded data, then how your latent space is used with your encoder and how the data is decoded with the newly reconstructed data. So this is the architecture of our autoencoders. Then application, where you can use these autoencoders in image compression, anomaly detection, data denoising, and feature extraction. So these are the areas where you can use your encoder and your decoder and reconstruct your own data, which is available with the similar characteristics. Next one is VAES, variational auto encoder. So this is a type of generative model that learn to represent complex data in a low dimensional latent space. It consists of a encoder network that compresses the input data into the latent representation and a decoder network that reconstructs the original data from its representation. So this mainly used for capturing the structure of high dimensional data, and it will resemble the training set, and these meaningful representations are used in data compression, anomaly detection, and data generation. So this is the architecture of your VAES. It takes the input to the distribution of your latent space and the mean and standard deviation of the particular data is derived from the decoder. Then decoder, using the decoder, and it reconstructs the original data as the input of the reconstructed input. X is converted with the mean and the standard deviation to X dash. Then applications, where you can use this image generation, anomaly detection, and data imputation. So we can use these variational autoencoders for data mutation also. Next one is GAN. So GAN is a very effectively used model under generative AI model. It has two neural networks, that is a generator and a discriminator. So this generator, the role of generator is to learn to generate the realistic data samples, whereas your discriminator will is trained, it's able to distinguish between the real and the fake samples. So they are trained simultaneously through a competitive process where the generator aims to produce the realistic data sample, and your discriminator will aim to distinguish the real and your fake samples. So mainly these are used in data distribution, image synthesis, text generation, and data augmentation. So this is the architecture. You have a two neural networks. One is generator, another one is discriminator. Then you have your adversarial training. So what we will do, we'll start with our real sample images. Then with the help of the generator, your discriminator will identify which is real and which is fake. And based upon the real sample images, your generator will generate the synthetic samples, and those samples which are created are identified by the discriminator whether it is real or fake. Then these are the applications. Image synthesis, you can use your GAN, data augmentation, and also style transfer. This is transferring the style of one image into another while preserving the original content of the particular image. Mainly this is used in your transforming a photograph from the training is done. So these are the applications. Next one is your transformers. So this is a neural deep learning model architecture. It's mainly used to your CNN and RNN transformers as the input data in parallel, making them highly efficient for sequence to sequence task. That is one by one task. That is the order of the task will be in sequence. So this model does mainly have the dependencies between the input and the output sequences, and it will have n number of hidden layers in between your neural network model. So the applications where you can use this kind of transformers is you can use in machine translation, text generation, and in the sentiment analysis. So this is the architecture. So you have an input text, and with the help of the encoder and the decoder, you have n number of transformer layers. So you will be encoding and decoding the original text as a output text. So you have a self-attention mechanism, then it will ask the work of the encoder and decoder will convert the content of the sequence by sequence, and your transformer block will have your self-attention and feed from neural networks until the representation is obtained from the input sequence to your output sequence. So these are the applications. Machine translation. So translating text from one language to another language. Nowadays, all the applications are bilingual. They have their native language transformation. Then text generation. So based upon the text, your transformer decoder model will predict the next word prediction, and it will generate the text. And finally, named entity recognition. We all know that BERT system is used for NER systems. Then RNN. So this is a type of artificial neural network effectively process sequence data by maintaining an internal memory state. So unlike your form feed network, your RNN will have the direct connections with the directed cycles, allowing them to exhibit dynamic temporal behavior. So the main purpose is it has to retain the memory of the past inputs and makes them ideal for modeling sequential dependencies and capturing the patterns in the sequential data. So this is mainly used in time series prediction, NLP, sentiment analysis, speech recognition, and your handwriting recognition. So this is the architecture. You have recurrent units that maintain a hidden state, allowing them to retain the information about the past inputs, input layer, in between hidden layer, then the output layer. So the input is given, receives the input and maintains the information from the previous time steps and produce the output. Then application, NLP, time series prediction, speech recognition, and image captioning. Then Boltzmann machines. So these are the type of stochastic recurrent neural network. They have interconnected binary neurons. They are mainly characterized by their symmetric connection between neurons. This is a bidirectional network flow. So they are mainly used for dimensionality reduction, and they have the future extraction and phase of the meaningful data can be extracted from the raw data, extraction of the meaningful information. Then this is the architecture. You have your input. From the input, they represent input in the form of the visible units and the hidden layers, then how they are interconnected, then how much energy function is deployed on that hidden units and the activation function. Finally, your stochastic process is used for sampling the model to update the neuron states. So this is the architecture. Then where you can apply this machines means in collaborative filtering, that is in your web mining or web content mining applications. You can use your collaborative filtering for the interactions of the recommender systems, anomaly detection, image denoising, and generative modeling. So these are the various applications where you can use your Boltzmann machines. Next one is flow-based deep generative model. So this is a class of generative model that learn the data distribution by transforming a simple base distribution into the target distribution through invariable transformation. So under your generative model, you have many submodels based upon the domain. You can use your model. So everything you'll be getting a input data based upon the model, based upon the data. You will be identifying the characteristics and you will be generating the new instance of the data for the further process. So this model is mainly used in density estimation, image generation. So this is the architecture. It has series of invertible transformations that map samples from a simple base distribution to sample from the target distribution. So you have access their input data and your output data is your X dash. In between you have your transformation layers, normalization of the flow and invariable constraint. From the flow you will be finding the function and the function will be understand the transformations from the network, and finally your inverse transformation is done with a new instant of the data. In application, where you can use this application means image generation, density estimation, then representation learning. So image generation means generating realistic images with high diversity as demonstrated before in our NVP model. Then density estimation is based upon the probability of the data and the distributions. Then you will be using your data compression and data outlier techniques to find the density, and finally you'll be estimating the density. Then last one is representation learning. So learning meaningful latent representations of data. Since you are using flow network, all your representations are downstream tasks like image classification and image clustering. So next model is neural cellular automata. So it is a computational model inspired from our cellular automata. That it combines both the principles of cellular automata and the neural network. It's a grid-like structure where each cell follows simple rules based on its neighbors as of our traditional cellular automata. So main purpose of this NCAS is to get the behavior of the pattern and finally finding the new instance. So the applications where you can deploy this neural cellular automata means image processing, texture synthesis, image generation and transformation. And also in the healthcare field, in finding the biological patterns also, you can use your cellular automata, that is your neural cellular automata architecture. So this is the architecture. You have your step 1 as your input layer. In between you have your linear layers as your input and your output with the hidden layers, and you will be having your new instant of your data. Application: image generation, rule learning, then computational biology. So it will generate images by iteratively updating the states of cells in a grid, and you'll be finding the patterns. From the patterns, you can have the new instant of that particular data. Then based upon the rules, association rule mining, you will be having your governing evaluation of cellular automata systems from data following the rules based upon the predictions. Then finally, cellular the automata can be used in your computational biology also to identify the genes, cell growth, behavior of the life systems, etc. Then these are the some of the recent breakthroughs in generative AI. So we have started with artificial intelligence. Then we have seen what is generative AI. Then what are the possible models in the generative AI with the architecture and the application. So these are the recent breakthroughs in generative AI. You have your GPT-3 by Open AI. That is a language model capable of generating human-like text and performing various language tasks. Then we have our Style GAN by NVIDIA, enables the creation of highly realistic and diverse images, revolutionary in the field of computer generated art. So you have your image is given, how your computer generated art will be there. Then AlphaFold by DeepMind. So it is a breakthrough in protein folding prediction, aiding in drug discovery and advancing in biotechnology. So these are the recent breakthroughs of our generative AI model that are mainly used in the environment. So here are the key players in generative AI: OpenAI, NVIDIA, and DeepMind. So ChatGPT is of OpenAI and StyleGAN is of NVIDIA and AlphaFold is of DeepMind. Then these are the main applications where you can use your generative AI: art and design, music, content creation, virtual worlds, fashion, financial forecasting, customer behavior analysis, demand forecasting, healthcare diagnosis, and finally finding the fraud detection. That is, it can easily identify the original and the fake. So applications in AI generated music, AI artwork, and AI writing. Where Chat GPT is a natural language generation capability. It will be used for automated content creation and storytelling. Then applications in healthcare. It mainly used in drug discovery, medical imaging, personalized medicine. So generative model aid in stimulating molecular structures and predicting the drug interactions, speeding up the drug development. Then it analyzes the medical images for diagnosis, early disease detection, and treatment planning. It helps the tailor treatment plans and medications based upon the individual patient data. So, drug discovery, medical imaging, and personalized medicine. So, these are the applications in healthcare where generative AI is used. Then, business marketing. In the business also, it is mainly used for making the efficient decision making process. So automation, supply chain optimization, fraud detection. So automation means you have all your chatbots. From the chatbot with the content generation tools, you can automate all the marketing campaigns and the customer interactions. AI algorithms optimize the supply chain optimization also, inventory management, logistics planning, and demand forecasting for the business. How to produce the product based upon the demand, it will forecast the future predictions. Then finally, fraud detection. So it will detect the anomalies and find the fraud, and also in terms of cyber security and financial activities also, all the cyber crimes are easily identified and it can be prevented also. Then entertainment. How generative AI is used in entertainment. AI in gaming, AI in films, and VR, AR. We already know that virtual reality. So whenever if you are joining any new college or new institution, new office, you can't go and view all the places in one day all around. So initially nowadays all the colleges are having their VR tour. So with the virtual augmented reality and the virtual reality, you can have the college tour or your company tour. You can visualize all the places of your college. So that is your VR, AR. So this generative AI model experience with the realistic environments, interactive characters, and immersive storytelling. So in the same place, you can have this VR, AR, and you can view the whole setup of your. You can walk through with your reality of your campus. So in the films also, it is used. It has realistic CGI, motion capture, and post-production tasks. Then education. How this generative AI is used in education. Personalized learning, content creation, language learning. So we have our personalized learning, that is AI platforms offer adaptive learning experience based upon the individual students need, their speed of learning, their style of learning. So it is personalized for them, for individual student. Each and every student is personalized with the platform. Then content creation, as chat gpt is the, we have seen the application based upon the requirement of the educational educators. They can create the interactive educational content, quiz, and also simulations. Then finally, language learning. So AI powered language tutors help learners speaking, writing, comprehension skills in multiple languages.
Hello,
So
madam.
you have already noted that we have large language models. So these models
Yes.
are mainly used in the generative AI. Then how this generative AI is used in fashion and product design. So in clothing, in textile industry, in identifying the material texture of the fabric, then the prototyping process, design iteration process, it can be used to create the multiple iterations and check the combinations of the textures of the fabric. Then collaborative design platforms, it can have a collaborative design workflows are dashboard. Then all the people can together work. They can work on the stakeholders to contribute ideas and they can get the feedback. Then finally, sustainable design and production. So they will, based upon our 17 sustainable goals, how this particular product can be eco-friendly and how it is meeting the demand. Then main thing is the privacy of the data and the security of the data. So whenever we are dealing with data, either it can be a healthcare data or it can be a finance data, all the data which are related to the individuals should be private and it should be secure. That is the main goal of the any model, to have the data privacy and security. So in your generative models also mainly concerned by the intruders, they have to provide security for the data whichever they are having in their database, and also for the new instance of the data. So how these attacks are handled, how intrusion detection systems will detect the security breaches, malwares, cyber threats. So everything should be under control. Then the data which are shared under the environment, either you can store your data in your cloud or you can store it in a distributed server. So the data which is shared also should be secured. So the main concept of any generative AI model is to preserve the data privacy and security. Even nowadays, many models are using federated learning concepts. So we are not going to share the data to the server or to the cloud. So each system, each user will be in a part from that, then the model will be running on their own machine, own server. So federated learning concepts with generative AI model will preserve the data and it will mainly helps in data privacy and security. So these are the some of the key issues. So if we are using these models, all our generative AI models, and we are going to apply in all the fields, so these are the some of the issues we have to resolve. Mathematical complexity, deep learning algorithm complexities, computational resources, ethical consideration, lack of labeled data since you are using your unsupervised machine learning algorithms, then the complexity of the algorithm, then rapid technology advancement and interdisciplinary knowledge. So you will be using your data from all the disciplines. So these are the key issues of your generative model. Any generative model should be able to solve these issues. So same thing, your challenges and your issues are given: mathematical, deep learning, computational resource, ethical considerations, lack of labeled data, the complexity of the algorithm, and the growth of the technology. Finally, interdisciplinary knowledge. So how the algorithm complexities and all these things are reduced. So whenever we have taking the model of this, we all know that NP hard, NP complete, NP value, P value, so algorithm complexities. So usually in all the data structures, you will be writing all our algorithms and will be finding the complexities under multiple mutations. Same here, you have your large scale GANs, autoregressive models. It will work on massive data set and it will consume significant amount of memory during your training and inference. So every model should plan it prior to start with the data. Then lack of data. Since labeled data is essential for training supervised machine learning models, also it includes generative AI algorithms. So this large scale label data sets should be present for image generation, text generation, and also in the process of creating the design of the data. So this unlabeled data will yield to low quality of training and performance of the AI model. So labeled data often requires manual annotation by human annotators, but it is a time consuming process and also it is very expensive. Then ethical consideration. Whatever we do, we should be ethical. We should obey to the ethical value of that particular domain. So you have to take care about the ethical principles, moral of the domain, integrity of the data, then responsibility of the user. So all these ethical considerations should be taken into account whenever we are developing our AI model. So we should not uh, have any risk on the individual's privacy, security of the data, since this type of data is mainly used in healthcare, education, finance, business. So all there should be some moral values and ethical consideration should be maintained. Then algorithm complexity, the algorithm which we are choosing on the GAN model, RGPT model, or your transformer model, the complexity of the algorithm with the scalability features you have to take care. So some of the solutions given for these issues in the generative AI, you can use your model optimization, resource management, scalability and efficiency, then training enhancement, how we are going to use the pre-trained models, then how this optimization algorithms reduce the training time and cost. Then the memory and the storage of the data. So you can go for your sparse models or you can go for the data compression techniques. Then how this energy conservation is done with renewable energy, then how fairness is maintained with the matrices and the mitigation techniques which are used to ensure the equitable performance. Then the security measures, how the data integrity, the audit of the data, and how the security is enhanced by process of robust testing. Then ethical practice, you have some guidelines. It should be followed between the stakeholders and the business people, and the transparency should be employed. Then finally, data privacy preserving techniques. As I told you, differential privacy or federated learning concepts can be used, and they can provide the user consent to protect the data privacy. So these are the some of the generative AI tools. So Chat GPT, Scribe, GitHub, Gbard, Cloud, GPT-4, Alpha Code, Duet AI, DAL E3, E2. So these are the versions and these are the some of the generative AI tools. So limitation of generative AI models, the quality of the content, the requirement of the computational model, then prejudice and fairness of the generative model, explanatory and interpretability, security, protection, and lack of common sense. So these are the some of the limitations of generative AI model. Then security challenges from the attacks, malicious attacks, bias and fairness, data privacy concern, and model misuse. So these are the some of the challenges with respect to security. Then, as I told you, the ethical considerations in generative AI, transparency, accountability, responsible use, bias mitigation, privacy preservation. So how it should be understanding the responsibility of the decision making process. It should be accountable and all the decisions taken should be transparent, and whoever using the particular generative AI model should adhere to the ethical guidelines to prevent and intern the harm and misuse of the model. Then counteracting the biases in training data to equitable outcomes. You have to mitigate all the malware attacks, malicious attacks, then finally safeguarding the individual's private information during the generative AI application. All the privacy of the individual should be taken care. So conclusion. So the future of the generative AI holds the breakthroughs in creativity, problem solving, and human computer interaction. So the revolution is from all the parts of the domain industries, innovation, marketing. So it is from diverse applications with the interdiscipline data. So whatever technology says, we have to use the human intervention also. Then you, in any point of time, you are not behind the technology. You have a hold on your own individual impact. Thank you.
Prasad garu.
So, dear participants, anyone have the questions or doubts or suggestions from the madam, you can ask now.
You have any doubts or any application or any questions how to work on generative AI models?
It was nice presentation, madam. Can you share it with us?
What do you want in this presentation?
Yes.
Yeah, I will share. It's just an introduction, ma'am. Yes, you need, I will share it. But along with this, you will have a term called large language models that mainly give you the algorithmic representation of the generative models, how actually it works on LLM.
Any other participant?
Can you tell me what the steps? Hello, ma'am.
Proceeds.
Yes, ma'am. Yes, tell me, ma'am.
Ma'am, please tell me about GAN.
What, ma'am?
GAN.
GAN.
That is
Generative
one
Adversary
type
Network.
of general adversarial network, ma'am. It's a type
ma'am.
of network, ma'am. Generative AI model. This is mainly used in the class of machine learning framework. So it has a two neural network process, generator and the discriminator. So what you have to do means you have to first start with your any data, fake data from any random noise, and your discriminator will evaluate the real data and your fake data. The generator will use the feedback from the discriminator, and it mainly uses the weights aiming to the realistic data. Ma'am, you have so mainly this type of application is mainly used in data augmentation, image to image translation, video generation, image generation. So if there is low amount of data, you don't get a perfect data, or if you are having a real-time data with many noise, you can use this type of neural networks, ma'am. So simultaneously, they can be trained through adversarial process, and they can break down and they will work, ma'am. Mainly it is used in security purpose also. You can use in cyber security, cyber crime, all those stuffs, ma'am.
Okay, ma'am. Thank you.
Thank you.
Ma'am, how is annotation done here? Annotation of data.
Ma'am, that is based upon the domain, ma'am. In which domain, what type of data you are using.
Okay. In case of text data, if I want to.
Any type of data based upon the domain.
Okay.
you can use it, ma'am. What is your requirement from the data? What do you want from the data? How it to be annotated?
Okay.
So in the context of machine learning or unsupervised learning, then whether your data is labeled or unlabeled. So for what you are going to use, for what you are going to annotate, what information you want from your training model. So everything plays a
Okay.
vital role, ma'am. Where you are going to
Okay.
use.
Suresh
Basic-
Sappa sir, you raise the hand. Do you have any doubt?
Yes, sir. Yes, sir. Sir,
Yes.
I am also raised about generative adversarial networks. I cleared that answer. I understood the answer. About GAN, sir, generative adversarial networks, I am going to ask. Already, some madam was already asked about GAN and the generative AI applications.
Okay, sir. Okay, sir.
Madam, about this GAN's generative adversarial networks, only in security purpose we are using, sir.
Mainly used, sir. Mainly used. Because you have generated and discriminated, there are mainly these machine function is to train and it evaluates and classifies the real data and the fake data, sir. So what our generator of your GAN will do means it will get the feedback from the discriminator and it will get the adjust the weights and aim to produce the realistic data, sir. So the main objective is you have a function in GAN V of D comma G. You have a function, so it will have the probability and the distribution of the data. You have it, sir.
Okay. Thank you, madam. Thank you.
Thank you, sir. Thank you.
So, Somalika madam, you raise the hand 3 times.
Yes, sir. Yes, sir.
You
Can we use
ask
these?
me.
Can we use these generative AI tools for creating data set, madam?
Yeah, of course, ma'am. You can use it, ma'am. You can use.
Okay, ma'am. Will you please suggest some tools, ma'am?
I have listed some tools, no, ma'am.
Okay, ma'am. Please, I request you to share this PPT for us, ma'am.
Yeah, sure, sure. I will share, ma'am.
Okay, thank you, ma'am.
Thank you very much, madam. It's really a wonderful presentation.
Thank you, sir. Thank
And
you.
it has covered both machine learning as well as this generative AI tools also. I think you have listed many tools on that last slide, last but one slide.
It is an emerging technique, sir. You have to deploy with many of them are free tools also, sir. So
yes,
you can
yes.
use it also. Licensed from.
Even the Google, Microsoft, Meta people are working on this LLMs more now. The entire
Yes,
Prasad, sir,
so
please proceed.
LMR model will supporting large training sets. Sir.
Yes, yes. That's
so nowadays many of them are using LLM model only.
Training in the rate of millions, like the data set is in the yes, that's what I have seen in the morning.
Okay.
And this
yes. large amount of data, then maybe for this NLP and bilingual characteristics and all, they are using LLM, but all our chat GPT is using LLM. Only,
yes. Even the Palm from Google, Meta, and even the chat GPT, which was taken by Microsoft, all these people now they are using this one. Thank you very much, madam. Prasad, sir, please.
Okay, sir. Thank you, madam. Very nice presentation. So many persons are trying to interact with you, and we are giving the best answers for them. And many of the participants have the doubts, but through your presentation, we are giving the best answer to everyone. Thank you very much, madam.
Thank you, sir. Thank you, Kiran sir.